Hi, this is Mohammad Saifuddin Chaudhry, and today I'm presenting one of our lab regarding Internet of Things, Arduino, and LabVIEW Linux. The presentation outline will be Arduino as Internet of Things, Arduino PI controller to control an air heater, data storage in the cloud through Thingspeak cloud storage, and LabVIEW Linux toolkit used with Arduino to control this air heater. What are the methodology I have used in this lab? First step is creating an embedded Arduino PI controller from scratch and low pass filter. Second is air heater temperature. This PWM output used to manipulate air heater with RC filter circuit, and then air heater temperature data logging to Thingspeak cloud, and finally we compare our Arduino result with LabVIEW. So in that case I've used LabVIEW Linux toolkit, which will manipulate in the air heater and which will control the air heater actually. And I have also used Arduino with LabVIEW as a dock device, since the NI hardware is expensive, so we are trying to overcome this expense. And here is Arduino PI controller to control air heater. This scratch. First step is create an embedded Arduino PI controller from scratch, and we need to create library for that. This controller, low pass filter, as well as air heater also for simulation purpose. Low pass filter I have used here to reduce the noise from the output signal, since we are using PWM signal, because we don't have any analog output pin in Arduino. So that's why we are going to use here PWM. So to reduce this noise and high frequency noise, that's why we used here this RC filter in the both form, as a resistance and capacitor, this RC filter, as well as this SPI bus. So here, this is the model of low pass filter, which is very important to reduce the noise and to make the operation smooth. So this is the noise is high frequency signals, which typically we don't need in our system, as well as this low pass filter will make sure the frequency, the low pass frequency, it will let into go to the system, and it will remove the high frequencies. And this is the equation which I have used in my library function. Now let's go to the Arduino IDE software. Here, this is my software, this Arduino software, and I have developed this simulation code, since I don't have this air heater now, and I have already completed this physical air heater interfacing in lab, and now I'm going to run this one. Yes. So I will load it now. So it will show the PI controller performance here. As you can see, my set temperature is 28, and it's trying to reach 28, and it's very smooth, and I can say like it's almost a fast controller as well as. So here, in the meantime, I can show this library file also, which I've created. This is for PI controller, and this one is for low pass filter, as well as, since I'm using simulation now, that's why I have used this heater mathematical model inside my Arduino code as a library function. So if I see now, it's almost reached, and it's like maybe 0.01 the difference. Now I can show this one as well as in Thingspeak also. So this is my separate code. I have done this one to make the storage in cloud. It takes a little bit time to upload. Now it's uploaded. And this is my serial plotter. It will start now. Yeah, it's started. Now I will check. Now I will check here in my data. Yes. So the last data, I want to refresh this one. This is the field 1 chart. This field 1 chart I am using now for Arduino. Later on, this field 2 chart I will use for LabVIEW. Now, as you see this one, this is the same time. Yeah, it's now 26.36. So data is logging now here in Thingspeak website. So this is the main task, so that we can control this air heater by using this PI controller, as it's going really very fine, and PI controller is working very fine, as well as this data is also storage. This data storage, as you see, like it's storing now, it's a very recent value. So this is the part with Arduino. Now I will go to my next part, and the thing is, I have used in lab this RC filter to reduce the noise, as well as this SPI bus also. Now the end part is LabVIEW Linux toolkit. I have also used. This is a different platform, and this one I've used to compare the output efficiency or performance, as I can say, like performance of controller. So I've used here this Arduino Uno. This Arduino Uno also used as a duck device only. So it doesn't have any impact except duck device. It will give only this sensor digital bit, and it can pass this PWM also to the air heater. So this is the kit, Linux toolkit I have used to control this air heater. So I can show you now this air heater model in LabVIEW. Yeah. So this is my LabVIEW code. Sorry, this is for simulation maybe. Yes. This is my LabVIEW code. Here I have used this state space machine structure. This is a very powerful structure for industry, and this case structure I have used. And there are different cases like initialization, wait, read temperature, and this controller part, and then write to the Thingspeak, and then exit case. So this is my initialization part, where I have initialized this serial port and this OpenVI, as well as this Linux toolkit I have used here as a reference source. And then after this case, it can go to the wait case. And this wait case, I have used here event structure. This event structure is by default, this will show here, and this is the elapsed time, because we can store our data in Thingspeak every 15 seconds with the free version. So that's why we have used this elapsed time, because we are going to log our data is each like every 20 seconds we will store our data. So here, this is our event structure and wait case, as you have seen here. So if time has elapsed, then this case it will go to the read temperature. If time has not elapsed, then it will remain in wait case. So let's assume this time has elapsed, and it will shift to the read temperature. So let's see this. What is read temperature? Here is the read temperature, where we can read the temperature from Arduino analog pin. This is the temperature sensor output. So since this sensor output, we can measure it here. And then after having this one, after completion of this read temperature case, it will go to the controller case. So let's see what is controller case. Here I have used PI controller, as well as this PWM set duty cycle so that I can control this air heater. And this is the pin number 6, which I have used for PWM channel. So after controlling this part, where this case will go, it will go to the write to Thingspeak. So let's see what is write to the Thingspeak. This is a Thingspeak cloud storage, so I can store my data in this Thingspeak. This is the SubVI palette program I have used here. Inside this one, you can see this is the thing, the code, this block diagram to store this data. So here the server name, and then as you can see, this URL is here. So same server name and URL, and this write API key, we need to write our data into the Thingspeak. And if we want to read data from Thingspeak, then we need to use this read API key. And from which field we are going to read and to which field we are going to write, this field number we have to define here. And this is the value what we will write in our website Thingspeak. So in our case here, we will write the temperature value from air heater. So this is the case Thingspeak, and then we have exit. So this exit we can have from wait event structure also. If you see here, this is my exit case. If I push this exit, so it will go to the exit case. So this is my exit case. This is the exit case which will disconnect the LabVIEW from the Arduino. So this is my real system, and I have already tested this in our laboratory, and it works really very fine. Now I will, for the sake of this making this video, I have created one more palette, one more program for simulation. So this is the simple simulation I have prepared, and here I have used this PID controller, as well as I don't have air heater. That's why I'm using this model air heater. And then I'm just using this elapsed time to store my data into the Thingspeak. So this is a case structure for Thingspeak. So I have already run this one to save time. So now I can show you the performance maybe. Yeah. So if you see here, I have increased my set temperature, and my control signal also increased. If I can increase more maybe. So my control signal is increased. Now if you see here, the set point is 34 and output temperature is also reaching 34 now. Now if I reduce my temperature, let's say 28, now control signal is also reducing somewhere else, and yeah, now it's 28 set point, and output temperature is also trying to reach. So I must say this is also like very good controller and it's yeah, it's working very fine. So yeah, as you're seeing here, it's yeah, almost 28 point something. Yes. Now the thing is, I will check the data logging also. The data logging in Thingspeak. Yes. So here, as you see, this chart I'm using for LabVIEW, and this chart for Arduino. So this is the LabVIEW. Last point is 28.39, and yeah, second point is coming here. So it's working very fine. The controller as well as the data storage part also. So here is my LabVIEW part, and this is the conclusion. So I have to compare my result with Arduino with Thingspeak, and as well as this LabVIEW with Thingspeak. So I must say the difficulties of Arduino based application are user interface design. this, while LabVIEW is an excellent utilities for the panel design. So like as I have shown you, like I can see this temperature graph, everything in LabVIEW, but I cannot yeah, I can do this one in Arduino also in this serial plotter, but it's this user interface is not that much good with Arduino. As well as if I in LabVIEW part also there is some limitation, because like NI hardware is very expensive compared than Arduino. But in this experiment, in this laboratory experiment, I have we have done this like Arduino Uno as our DAC device we have used. So we try to minimize the cost actually, and as well as the overall performance. If I want to discuss this one, the performance of PI controller to control the air heater circuit is faster and smoother with LabVIEW. While on the other hand, the Arduino performance was a bit slower, I must say this one. So this is the ending, and thank you for watching. And one more thing I can actually tell this one, like this project is like very handy project which we can use actually. I'm thinking like in any type of industrial project, like engine stroke engine stroke count maybe, so that we can calculate the life cycle of cylinder actually. So like many projects we can use this one. It's not only in air heater, we can use this one is water tank, we can use this one for air cylinder performance, like lots of industrial project we can use this one. Okay, thank you very much for watching. Thank you.